Hello fellow cavemen and rockmen of internet. I am Rockman Ray. I will teach you how to do trig. As I am learning trig in high school, I have decided to kind of relay what I already know to you guys. So I hope this is a helpful guide. It is supposed to be an extensive guide on everything I know up to this point. So let's start. In our first unit, we are introduced to trig, and there are certain identities we need to know. So first on the docket is sine, cosine, we got tangent. Yeah, all right, so these are the basic identities, and they go as TOA, CAH, and SOH. Now what these are basically sine is opposite over hypotenuse, so it's the opposite of whatever angle over the hypotenuse. And then you got cosine, which is adjacent over the hypotenuse. And then you got tangent, which is the opposite over adjacent. Now, all right, you might be asking, well, what do I do with this? Well, you're going to be given like a triangle like this. Then it's going to be like probably a right angle all the time. And it's going to be like, let's do like the 30, 60, 90s, because this is eventually what I'm going to teach you guys. So it's like, okay, this is 60. This is 30. All right. And so there's one example. There's also 45, 45, 90 triangle. But let's do this one first. So we got the 2x. We got the 3x. We got the x. All right. So normally some of these are given, and then you have to like find the missing length. So in this case, let's just find the cosine of 30. Yeah, let's just do cosine of 30. Cosine of 30 would be like, adjacent over hypotenuse. And basically what that is that this is adjacent to this angle. So you got root 3 over, of course there's an x here, but and over, adjacent over hypotenuse, so it's 2x. Now these x's go out, and then you got 3 over 2. So 3 over 2. Cosine of 30 is 3 over 2. And we got sine of 30, which is, opposite over hypotenuse, which is, what's the opposite of 30? The opposite of 30 is x. So we have x over the, hypotenuse, which is just 2x. X goes out with x, so it's just 1 over 2. So sine of 30 is 1 over 2. All right. So you might be wondering, well, what's 45, 45, 90, and what difference does that have? Well, all right, let's do that right now. We got the 45, 45, 90 triangle, which is 45. We got 45 and 90. Okay. Now, 45, 45, 90, you have that 2x. You have the x, and you have the x, right? All right. This is root 2 of x. So, all right. Let's just do the sine and cosine of this. So cosine would be, cosine of 45 would be, adjacent over hypotenuse, which is this one, like let's say this one. So you'd be like, adjacent, right? X over root 2. Just goes out, so that's just 1 over root 2. Now you can't leave this as this, because you can't have a root in the denominator. Like never have root in denominator. So you just multiply it by root 2, right? And when you multiply it by root 2, this one turns into 2, and this one turns into root 2. So it's just root 2 over 2. That's the cosine of 45, 45, 90. And the thing is, the sine of it is the same as well. So you don't even need to do this a second time. It's just the same thing. So you just put like sine of 45 is root 2 over 2. All right. Now, so now what you need to focus on is that this, when you're solving for this, you have to look back to the original one. So you're going to say like, what's the opposite to the 90? So the opposite to the 90 degrees is 2x, right? And like, what's it called? What's here? Oh, x. So we found x. We essentially found x. So you just do like 2 times what you have, because coincidentally x is given. So you got 14. And what's 2 times 14? It's 28. So x is just 28. So when you have 28, well, you have 28. So now you have this. You would say, oh, this is this, right? Okay, but no, because this has a root 3. Oh my God. So simple. So you need to just make sure that you don't forget this. That these variables are here, or it's going to be wrong. So I'm just going to draw it again for just clarity. And then, well, your x is 28. So that's that. You got a 14 back here, and then you got, well, wait up. I actually made a mistake here because, yeah, this is 28, but that doesn't mean that it carries over to here. So our x is just this x. So that's why that's a different variable. All right, so it's just this x. So for our example, it's just 14, and then you see this root 3. It'd be like root 3. That's it. So it wouldn't be, what I was thinking was 28 root 3, but that's not correct. So five, 45, this is 90, and then you got the 3 root 2 over 2. Okay, what is this thing? Oh, you might see. Okay, this is the back. You should probably have this memorized in your head, so let's just go over this one more time. Opposite of 90 for 45, 45, 90 is root 2. And then adjacent to 90 is x. And opposite to 45 is x. And for 30, 60, 90, opposite to 90, which is hypotenuse is 2x. Adjacent to 30, or this one, is root 3. And opposite to 30 is x. So we just go back here and we're like, how do I find this? All right, well, I know that this and this are the same because opposite and adjacent are going to be the same because these two are x's. So these two are x's and normally this is different. So, all right. So we have 3 root 2 over 2, right? Yeah, 2. And then this would be, you gotta think, you know? You gotta be like, big think. And then you go, well, all right, there is obviously a root 2 here. So what would I do when there's a root 2 times my 3 root 2 over 2? All right, so this would be just multiplied to that. Just imagine there's a 1 under here. So this would be like 6. So this would be like 6 over 2. What's 6 over 2? 6 over 2 equals 3. So that means that I'm just going to write this again. So that means that we have 45, 90. And essentially, we got our 3 here. We got our 3 root 2 over 2 here. And then we got our 3 root 2 over 2 over here too. Okay. And that's the finished part. So 2 over 2 over 2. Wait, what? Yeah. Over 2. Just 1, 2. Okay. Got it. Good. Alright. So the next part is actually finding theta. Or find the angle indicated. So let's do a classic one, which is this one, I think, right? Yeah, it is. All right. So this is very confusing, especially if you're trying to find a missing angle. This is theta right here, right? And this is the 90 degree actually, and this is 12. And this is 13. So your sides are given. So you got 2 sides, right? And these sides are, given. So what do you have? What sides do you actually have? Well, we know that the side opposite to the right angle is the hypotenuse. So you know that 13 is a hypotenuse. And you know that, the side below the right angle is actually the adjacent. So you know that 12 is adjacent. So given that we have these two, we can assume that it's cosine. So you could say like cosine of theta is equal to, what's our hypotenuse? 13. What's our adjacent? 12. So 12 over 13. Yeah. And then, so what you're going to have to do is actually bring a calculator for this. So I'm going to be right back. Whoa. Now, all right, we're back with the calculator and we can figure this out. So this is cosine of theta, which is actually this. So you click second and you do, second, and then you do cosine, and then it inverses. So this one, the -1. So when you write that, you just do 12 and then divide it by 13. And you close it. And then you do equals. And then that is your answer. That is your theta. So that is this. That's this thing. So that's just 22.62? 22.62. Okay. So that's your 22.62. And then you clear that, and then next one. So let's just find another one that's just annoying as this one. So I'm just gonna draw this base here, and we got this, and then we got this thing. Oh my god, what is this already? Like, this is boring. Look at this thing, dude. Anyways, from the direction it's positioned, you can obviously see that this is a hypotenuse right here. And our hypotenuse is actually given. So that's our hypotenuse, and this is our theta. So that's our theta. That's what we want to find. This is what we want to find. So 6. We got 6, and these are all the things that are given. So we got an what is this, dude? Okay, we got a hypotenuse and we got an adjacent. Yeah, so that's an adjacent. Because yeah, it's an adjacent. All right. Because okay, look at it this way. Look at it this way. That's a hypotenuse. That's an adjacent. This is an adjacent. All right. Now we just do cosine of theta, because it's opposite. So because it's adjacent over hypotenuse, so it's like 6 over 9. And then you grab a calculator and you do cosine of 6 over 9, and then you do enter. You got 48.2. Yeah, 48.2. So cosine of theta here is 48.2. There we go. So this is that. This is this thing. All right, we got that down. So let's go to the next page and get our next trig lesson in, because this is probably very important. Oh man, gotta love this one. All right, these are positive and negative coterminal angles. So positive and negative coterminal angles. Just get that in. It's so. Alright, so first we start. It's pretty easy. So it's 310 degrees. And it wants this. It wants the positive and negative degrees of 310. Well, what do? We do plus and minus 360. And effectively, that just gives us 670 and negative 50. So these are our coterminal angles, and coterminal angles can have negatives in them, but later we're going to learn that reference angles do not. So if you're getting like a reference angle, dude, reference angles do not have negatives. So if you get a negative out of solving a reference angle, you're doing it wrong. So in this one, we're going to actually solve for a reference angle. But before we do that, let me just do a negative version of this. So negative 9,195. So plus or minus 360. Right? And we got, well, this is 165 and negative 550. Yeah. So we got this. And we got this out of this. All right. Now, what we have to do is do the reference angles now. All right, I guess. So here it's really easy. Reference angles. You just have to look at this first. So you got a normal grid, right? And essentially, what reference angles are you got like 560. Let's go 560. So if it's positive, then it goes counterclockwise, right? And if it's negative, it goes clockwise. So what it goes is like, you think. Okay, let's just put this down first. This is 90. This is 360. This is 180. This is 270. Right. Okay. So this is 560, so we're going positive, so it's counter. So like you start from here, you go 90, 80, 270, 360, 332. You go here, right? Because it's like, you know, you got 360 and then you got 2, so it's obviously going to be in the third quadrant because math, you know. This is the 100, this is like the 100 zone, this is the 200 zone, and this is the 300 zone. So yeah, this is like below 90 zone, this is 100 zone, this is 100 zone, this is 200 zone, this is 300 zone, and then this is 360. So like 90, 180, 270, 360, like that. So you know it's here. So now what you need to do is you just need to write this down. So 560, this is 560. This was the route to 560. So 560. 560. Now you need to find this part. You see, this is the reference angle. This is the reference angle. So what you need to do is actually, all right, wait, let me scooch over. What you need to do is, because this is a special case scenario, this is above 360. If above 360, use 360 as subtraction or addition, but let's get into it. So if you do 560 minus 360, right, you get 200. Now what 200 is it's your reference angle. So we have our first reference angle down, right? And now we go to our second reference angle, like for something else, right? For like a different, oh my god, I already messed the grid up. All right, anyways, let's do a positive number. So 235. This is a different thing. So let's just divide this. All right. So we got 235, right? And 235 is counterclockwise. So, I think. Normally, you do 180. 180 if below 360. You use 180 if it's below 360. So we're gonna subtract 180 from this. So it's gonna be 235 minus minus 180, which is 55. So that means that our reference angle is 55, right? So because our reference angle is 55, we already know that we're just better. So we just have to find where 235 is actually. So we know that this is 90. We know that this is 360. We know that this is 270, and we know that this is 180, right? So from below 90 to 100s to 200s. This is where 200s are. This is 200 below 270, so this is 230 and 235. So, what do we do? What do we do now? All right, we draw, right? So this was here. So this is the terminal one. So it's 235, 35, and this is a reference angle. So this is 55. So that's how you find reference angles, and basic trick. Stop by for the next video because it's actually the continuation into the unit circle. All right, see you in the next ones. Take care, cavemen, cavewomen of internet. I teach you good stuff next time.